In this section, we are going to start talking about probability. Let's go ahead and start with a little bit of exploration, and then we'll come back and add some definitions. Now, these are the notes for my in-person class, so we're going to make some adjustments for this video. It says each group will be given one six-sided die. What are the possible outcomes if we were to throw this die? Well, in a set notation, the outcomes are just going to be 1, 2, 3, 4, 5, and 6. Those are the only things on this die. What is the probability of throwing a 3? Well, there's only one 3 out of 6 sides, so that will be 1/6. One side has a 3 out of 6 total sides. Now, for this next part, I would like you to find a single 6-sided die somewhere in your house and throw it 50 times and document how many times you get a 1, a 2, a 3, a 4, a 5, or a 6. And the way the table's set up is you can just make tally marks, which is where you just kind of write a little tick mark every time that number occurs. And then we could sum that up and find the percentages. If you do not have a physical die, we could use a virtual die. I found a few. I found this one on GeoGebra, this one on Dice Roller, and another one here, Virtual Dice Roller. I've only tried each of these a couple times. You can use whichever one you want. But essentially, you are going to roll a virtual dice 50 times. In this one, you have to set how many dice you want. And then the rolls are here. So I would do just one roll. So the first one was a 2. The next one was a 5. And then it kind of keeps track of it on a graph. So whichever way you want to do it, go ahead and pause the video here and do your 50 rolls. I paused the video and I also rolled a die 50 times, and these are the numbers I came up with. Your numbers will be different than mine. Now, the next row says percent made, and to do that, I'm just going to do the amount that I got divided by the total number of rolls times 100. So this will be 26%. This one will be 16%, 18%, 14%, 14%, and 12%. And that should all add up to 100%. Question 4 is asking us to compare the answer that we got in problem 2. In part 3, we got 18%. And in part 2, I got 16.67%. So problem 4 is saying, did these answers match? And they do not. And it also asks us why or why not. And I'm going to leave that for you to kind of think about why they don't match. All right, now that we have done some exploration, let's go back and add some notes and some definition to put context to our exploration here. The first is that this throwing the die 50 times, this is our probability experiment. When it asks for all the possible outcomes, this is our sample space. Throwing a 3, this is an event. When we found that the probability of getting a 3 is 1/6, this is called the theoretical probability. All right, and then down here at question 4, the reason that the answer to 2 and the answer to 3 do not match is something called the law of large numbers. Okay, let's formalize all of that with some definitions. A probability experiment is a process that leads to well-defined results. The sample space is the set of all possible outcomes. So, for example, in this problem, the outcomes would be 1, 2, 3, 4, 5, and 6. An event is one or more outcomes. A theoretical probability will be the number of outcomes in an event over the total number of outcomes. This was the answer to problem number 2. There's one possibility of getting a 3 out of 6 total. And then finally, the law of large numbers says that if we do something many, many times, the proportion of desired outcomes will approach the theoretical probability. So let's go back and look at that for just a quick minute. If we were to keep rolling our die, and we did it many times, this 18% get closer and closer to the 16.67%. And just to kind of show you that, I did my virtual die and I rolled it 1,000 times. And as you can see, the numbers are starting to get to be almost all equal. And in fact, if I change this to relative frequency, it gives me the decimal values. And you can see they're all getting closer to that 0.167. And I can even do 1,000 rolls. And you'll see that's getting very close. So that's the law of large numbers. So that is theoretical probability.